And this is part 4 of our series of Was the Moon Landing a Hoax? I'm going to be restarting uh, the last bullet I was working at the end of the last video. I ended up splitting a concept, so go and continue it because it makes more sense together. One of the things that people who are pro landing hoax will say is according to records, more than 1,400 solar flares occurred during Apollo missions. Well, the answer is the number represents the total number of detectable solar events, not major flares that would have posed a danger to the astronauts. The records also show that no major solar flares occurred during the Apollo missions, but the people who are pro hoax don't look at that closely. The impressively large numbers is all they're interested in. The closest call came when Apollo 12 spacecraft external radiation sensors detected a minor flare, but the interior sensors did not indicate that any appreciable amount of radiation had penetrated the hull. Uh, Another argument from the other side is during solar maximum, about 15 flares per day emit detectable X ray energies. Well, there's a huge difference between a major event and a detectable event. The records show that no major solar flares occurred during the Apollo missions. Major solar events last for hours or sometimes even days. That's true. Major events can last for hours or days. The events that occur 15 times a day during peak activity are low-level events that pose no particular hazard to the astronauts. Again, from the other side, solar flares produce huge amounts of radiation. One source says 3 million rem for a 1 year continuous exposure. Another source puts it at 100 rem per hour. The NASA site says the radiation approaches 10 million electron volts. So an electron volt is the amount of energy picked up by a single electron as it passes through an electrical potential of 1 volt. It takes the equivalent energy of about 620 billion million electric volts per second to light up a 100-watt light bulb. Another argument made is that the maximum safe dosage for a general public is 1 MSV per year and 5 MSV in special circumstances. The Apollo astronauts would have been exposed to several orders of magnitude more radiation than these figures allow. Apollo astronauts wore dosimeters to measure how much radiation they were exposed to, and sensors both inside and outside the spacecraft measured radiation. The highest exposure for Apollo 14 and the dose equivalent was about 2.85 REM or 28.5 MSV, or about 10 times the amount of normal background radiation per year, half the allowed yearly dosage for occupational radiation exposure, or 1/140th the lethal dosage. In some places on Earth, natural radiation supplies up to 280 MSV per year. Skin exposure is not as drastic as exposure in the blood producing organs, and since those organs lie deep within the body, they receive about 40% less exposure than the skin. Another argument is experts say that high energy protons travel at the speed of light, so there's no time to get under cover. Correct. Only massless particles, like photons, can travel at the speed of light. Particles such as protons that have mass cannot travel that fast. Another argument, the hulls of the Apollo spacecraft were ultra thin. Statistical probability was the main protection for the Apollo crews. The forecasters would have been able to rule out major events during the first few days of the mission, and also, and so out of the 9 day mission, they might have only had 5 or 6 days of vulnerability. The chances of a major solar event occurring within a given 5 day period is remote, even during periods of exceptional activity. Okay, solar events are directional. They don't fan out from the sun in concentric rings like an explosion. They're more like cosmic shotgun blasts. And even if an event should occur, it's more likely to throw particles in some other direction than that towards the Earth or its moon. Another argument given is NASA says that the solar event is the single greatest danger astronauts would have to face on a mission to Mars. Why wouldn't it also have been a grave danger to the lunar missions? Well, the answer is a mission to the moon lasts at most 2 weeks and has a good odds of avoiding solar events. A mission to Mars might last up to 2 years and has very little chance of avoiding a major solar event. Another argument talks about David Groves, PhD, showing the X-ray environment of space would quickly render photographs unusable. Well, in the experiment, Groves uses the wrong camera. He isn't using the same camera that was used by NASA. Uh, the manufacturer of the camera, Hasselblad, added additional protection to the film magazines. It's unclear whether he left the film inside its magazine as the Apollo astronauts would have done. Groves exposed the film to X-rays thousands of times more intense than what occurs in space. He used a linear accelerator to bombard the film with 8 million electric volts of X-rays. X-ray astronomers say the X-rays from celestial sources radiate energies at levels less than 5 kilovolts. Why didn't the astronauts smooth out the wrinkles in the flag? Because they thought it actually looked more familiar to have the flag slightly rumpled. The Apollo 11 astronauts could not get the telescoping crossbar to extend fully, and on later missions they intentionally didn't pull it out so they could mimic the effect. A couple of throwback arguments talking about how the Soviets were ahead of the United States. The Soviets had the first crew of 3 astronauts aboard one spacecraft. This would have been a good example if the Soviets hadn't simply stuffed a third man aboard their 2 man capsule just to set a record. To make room for the third cosmonaut, they had to take away the crew's spacesuits and remove other safety equipment. Although the Apollo capsule came a bit later than the Soviets, it was designed for 3 people and was superior technology. Another argument on basically the Soviets having a better space program was that they had the first spacewalk. As with the 3 man crew, this feat was achieved only at great risk. A makeshift airlock was attached to the capsule. Since only one of the astronauts could wear a spacesuit, cosmonaut Alexei Leonov was initially unable to squeeze back into the airlock after his spacewalk and got inside only by deflating his suit. Another throwback, the Soviets had the first 2 spacecraft rendezvous, and this is highly inaccurate. The Soviets staged a facsimile of a rendezvous by carefully timing the launch of a second spacecraft to place it in the orbit or very close to the first. It's not a true rendezvous. The first bona fide rendezvous occurred during the Gemini 6 and 7 missions, where spacecraft actually maneuvered within a few feet of each other. The Gemini program perfected the art of rendezvous with manned and unmanned spacecraft. It set records for endurance, altitude, and spacewalk duration, launch turnaround, and many, many other records. Okay, another argument is that to just run a moon landing simulation requires dozens of megabytes. It would require far more to accomplish the actual task. Well, first, moon landing simulations do not inherently require a lot of resources. They do on today's personal computers, but only in the sense that any task on today's personal computers requires lots of resources. That's because those computers have heavyweight and general purpose operating systems and are expected to provide lots of bells and whistles. Another argument that's made is that computer chips weren't invented in 1969, so there's no way NASA could have built Apollo computers. Today, a modestly priced microprocessor has registered memory cache, floating point processor, graphics acceleration built right into the chip. Not long ago, those added features had to be provided by additional chips. Putting a complete CPU on a single chip was a big breakthrough, but microchips performing simple tasks were available in the early 1960s, and these could be built into a processor just using multiple chips. Computers in the 1960s were huge, heavy machines that took up entire rooms. The most powerful computers of the time were bulky and took up entire rooms, that's true. And there's still powerful computers today that kind of match those requisites, various supercomputers. However, the Apollo guidance computer did not have to be extremely powerful. It was, think of it kind of like a Raspberry Pi, where you can get a lot of power out of something by stripping it down to its base essentials. The Apollo computer was a sole purpose computer. So it didn't have to worry about a major operating system or running games or anything else that we do on a modern computer. All it had to do was navigate the spacecraft to the moon. Another argument is during Project Apollo, 6 highly complex manned craft landed on the moon, took off, and returned to Earth using a relatively low level of technology with only one unsuccessful mission, giving it an 86% success rate. Since Apollo, 25 simple unmanned craft with increasingly higher levels of technology have attempted to go to Mars. Only 7 succeeded, a 28% success rate. Was Apollo just merely blessed? Well, manned exploration, space exploration is very dangerous, and therefore a lot of safeguards have to be put in place at a huge cost. The lunar module had 2 human pilots to correct in any deficiency in automatic guidance. If Neil Armstrong hadn't been at the controls of the Eagle and steered down to an alternate landing site, the ship would have likely been ripped to pieces on large jagged rocks that Armstrong discovered at the predetermined landing site. Things that make things more difficult is Mars has an atmosphere, which adds difficulty to spacecraft landing there. Martian landings are more complex because of the fact that it takes the radio signal several minutes to travel from Mars to Earth. There is little or no chance for remote control. You can't control the spacecraft in real time from Earth or receive real-time sensor information. So essentially, whereas the Apollo landings had the ability with humans being right in the loop and also being a short distance from Earth, if anything went wrong, either the pilots or ground control could make a fairly quick correction, whereas Mars, an error, once it's realized it's occurring, the event might be over and done with. I mean, with the spacecraft being destroyed or completely off target before anyone can do anything to fix it. Another argument is that we should be able to hear the lunar module's descent engine firing and the radio transmissions during the landing. Well, in space, no one can hear you scream. When firing in a vacuum, most of the rocket engine is silent. NASA tested the Mercury space capsules with animals. Why were no animals used to test the Apollo spacecraft? Well, the animal tests taken that were done during the Mercury project were not intended to test the spacecraft so much as it was to test the behavior of complex organisms in space. At the time, it was not known whether human beings could survive in zero gravity or survive the stress of launch and landing. The animal tests proved that complex organisms like chimps could survive launch, landing, and work happily in space, so no further tests were needed. If the suit's pressurized in a vacuum, they should bulge out, but we never see them when we never see where they look inflated. The suit is specifically designed with a restraint layer to prevent that from happening. I'm skipping over some of the stuff because it starts getting kind of. I mean, some of the arguments you're hearing, you're going, well, they're kind of lame. Some of them, a lot of the other ones are actually worse. uh, One argument is the lunar module was too unstable to fly. It would have been impossible for it to hover balanced on the thin column of thrust. Any movement by the astronauts would have thrown it into an uncontrollable tumble. In fact, every rocket must balance on its column of thrust, whether it's going up or down. The thrust vector must point very nearly through the rocket's center of mass at all times in order to avoid unwanted rotation of the vehicle. Early rocket scientists realized if they couldn't tell when a rocket was tipping and apply the correction quickly enough, they could stop the tip before it became a fatal tumble. Uh, Another argument made is the lunar module ascent stage could not gimbal. It was fixed in place, so therefore too unstable to fly. The same computer that controlled the descent also controlled the ascent. The same RCS that used to help to control the descent performed all the attitude control for the ascent. Second, the lunar module ascent stage is much more inherently stable spacecraft than the cylindrical rocket from an inertial point of view. Also pointing out that the lunar landing training vehicle, which was just like the lunar module, was too unstable to fly. Neil Armstrong had to eject because he couldn't control it. The test vehicle piloted by Neil Armstrong crashed in May of '68, and that's because of a helium pressurization system for the steering jets failed, leaving Armstrong no way to control the vehicle. This was not because the vehicle was too unstable to control. There were two other crashes too, one in December of '68 and another of January of '71. By April of '66, the test vehicle had already performed more than 100 successful flights. Another argument made is the Vomit Comet that was used to stage zero gravity segments of the Apollo missions, just as it was for the motion picture Apollo 13. The video from the command module during the coast phases of the voyage was broadcast seamlessly with no breaks or cuts from one camera to another. That's talking about the movie Apollo 13. There was only one camera. The parabolic flight path method only works for about 30 seconds at a time. Without being able to stop, cut, and splice, it would have been quite impossible to use this method to produce a seamless video presentation lasting several minutes. It works for Hollywood, since a take only lasts a couple of seconds anyway. And now get into really what is probably the biggest problem is the scope. There are several problems with the general scenario of the idea of the lunar missions being faked. First, scale. At the height of the Apollo project, almost 500,000 people were working on it. Yet, in all of 30 years and more since that's happened, not one of these people has come forward to say that they were part of the conspiracy. In all these people working, one would presume there were disgruntled employees, yet not a single one of them came forward to give away the dirty little secret. There's no particular evidence that a reward was given, like a huge payment to keep people quiet, especially at the scope of how many people were involved. And even if you pick the key people, I don't think anyone was looking at the astronauts of being essentially multi-hundred millionaires. Money moving of that quantity moving around even back then was fairly easy to detect. Nobody left a deathbed confession. No package to be opened after their deaths or anything like that appeared. So there's a couple of different concepts you could throw in there. We call the minimum scenario. At one end of the spectrum, we can consider the possibility that only a few top people at NASA knew of the conspiracy, and so all the contractors and most of the folks working for NASA truly believed that the lunar landing was a fact. The big disadvantage is that the contractors now believe they must actually build the space hardware. Grumman must actually believe it's building a lunar lander. North American must actually build a command module. Boeing and others must actually believe they are building a moon-capable rocket. Integration teams from all these companies must make all these products work together. Quality control officers from NASA must meticulously inspect the work. In short, the scenario will produce equipment capable of going to the moon. But our cardinal premise is that NASA couldn't do it. So if all the equipment worked, then what's it to prevent NASA from actually performing a lunar landing? Okay, then there's the need to know scenario. Only the people who really need to know are let in. It comes down to whether one tells the contractors or not. If you leave the contractors out of the conspiracy, you get a viable space hardware and then no real reason for a hoax. If you tell them, you get the big conspiracy with too many loose cannons. Once you tell the contractors, you bring in a whole lot of people. Each contractor has its own hierarchy of leadership and management, and senior engineers will have to be told. So you're talking about something that's going to end up absolutely chaotic. It can be argued that the average production line employee wouldn't know whether or not he was building real space hardware. But you can't easily compartmentalize the engineers. Even the junior engineers in an aerospace venture require the big picture in order to do their work. You'd have to buy off enough of the workforce in order to produce convincing hardware without producing working hardware. In short, there's no middle of this road. Either you produce real hardware or you have a very large conspiracy. Another item that's fairly critical is essentially how many other nations would have to be involved with the conspiracy. The ability to track a craft via radar or using radio telescopes to track telemetry is relatively simplistic stuff. The Soviets were already doing things along these lines, so they would have had the capability of telling that whether or not we got a craft to the moon. By the way, might be fireworks. Happy 4th of July. But anyways, the Soviets would have known whether this was working or not. And so part of this conspiracy requires them keeping quiet about it for some reason. That also requires any other advanced nation on Earth that had a capability of doing that, several European countries. It's highly implausible at that point. And so really the main things that come together to cause the problems is that your most viable argument would be the radiation argument. Yet, if we look back at most of the sources for why it shouldn't be able to work, clearly most of the people don't really understand the difference between waveform and particle radiation. And they seem to dig in with their lack of understanding and just say, well, I'm going to refuse to understand how this works and just say, because somebody else told me it doesn't work, it doesn't. The other problem is the scope of the conspiracy in terms of all the people working on it within NASA or supporting NASA. And then finally, the international conspiracy of the Soviets basically letting us get away with this. And all those together don't really add up well. I'm going to end this. I'm going to have one last video. I had several people chime in on the comment section. I'm going to use an opportunity to speak to their concerns and give some answers to it. Hearing the real voices of people who believe the moon landing was a hoax. I think it's fair to give them a chance to express their point of view. And some of them brought up some good points that forced me to do a little bit of looking, which is always good stuff. All right. Tell me what you think below in the comment section. How could essentially the vast NASA aerospace complex build a system and nobody talked about it? How can a system, how can a spacecraft either not go to the moon or go to the moon without astronauts in it? How can this occur without the Soviet Russians being part of things? What would be their motivation to let us get away with it? So answer that in the comments below if you have thoughts along those lines. Please smash the like button. If the YouTube algorithm brought you here and you're not a regular subscriber, please take a look at my other titles. I'm sure you'll find something you might find interesting. Consider subscribing. And if you know somebody who might find this interesting, please share it with them. Thank you for spending time with me this evening. Hope to see you again in a future video.